Hello everyone and welcome to this video. My name is Cliona, I'm a H1 chemistry student, and today I'm going to be taking you through the solution to this question from the higher level Leaving Cert paper from 2020. And this question is based on rates of reaction, and it's based on the experiment question which investigates the effect of temperature on the rate of the reaction between a sodium thiosulfate solution and a hydrochloric acid solution. Okay, so you can see here you're given the table where they recorded their results. Okay, so you have the run or the trial, you have the temperatures, the time taken, and the rate. Okay, and the rate is 1 divided by the time. So question 8 tells us, with the aid of a labeled diagram, describe a method for adjusting and measuring the temperature of the reaction mixture for the runs above room temperature. Okay, so there's 9 marks going for this question, and they are broken down into 3 parts. So the first part is the method for adjusting the temperature. So I said that I placed a flask containing thiosulfate solution in a water bath on a hot plate, okay? You could also say you could put it in a water bath on a Bunsen burner, okay? Whichever you used for yourself, for your own experiment, so that might be fresher in your mind, okay? So you're going to get 3 marks for that, okay? So then you have to add hydrochloric acid to the flask and mix it, okay? So you're going to get another 3 marks for stating that you're adding hydrochloric acid after the thiosulfate solution was in the water bath, okay? And on the hot plate or the Bunsen burner, whichever you use to adjust the temperature. And then you're going to go to the part where you measure, okay? The method for measuring the temperature, and that is going to be your thermometer. So place the thermometer in the flask to monitor the temperature, and you're going to get 3 marks. Now, if you leave it at this, you're going to lose 3 marks because you've no labeled diagram. So here's my labeled diagram down here. So I have my hot plate, I have my water bath, my conical flask containing thiosulfate and HCl, and you have my thermometer, okay? So this is, if you, as I said, you're going to lose 3 marks if you don't have the diagram. You could also get all your marks in the diagram, provided that it's more detailed maybe. So if you just had your diagram here, you'd want to say thermometer in conical flask for measuring temperature, and you could say hot plate down here and state that the hot plate is going to adjust the temperature, and then you could state here that your hydrochloric acid is going to be added afterwards. Okay, so now let's go back to the question. So we have question A done. Let's move on to question B. Question B is broken into 2 parts. The first part asks us what was observed in the reaction flasks during each run. And the second part is asks us how to describe how this observation was used to obtain the reaction times. So what was observed in the reaction flasks during each run, okay? This is basically just, if you're looking at it, you're not a scientist, you're not even studying chemistry at all, okay, what is actually happening? And anyone can tell you that when you're mixing them, that a pale yellow precipitate will appear, okay? So you're going to get 3 marks for this. You might also, or you will also, my apologies, in this question, get your 3 marks if you say that a cloudiness appeared, or an off-white colour, or a cream colour precipitate appeared. So you're literally just saying what you're observing. So now the next part of this question asks us to describe how this observation was used to obtain the reaction times. So the reaction times are the times that it takes for it to react at each different temperature, okay? So they're basically asking how are you going to get different reaction times based off this observation, okay? So you might remember from doing it yourself, you probably had a laminated cross. This is what we did for my Leaving Cert anyway. We had laminated just a picture of a black cross and put it underneath the conical flask, okay? And then we recorded the time it takes for the cross to be obscured. And this means the cross to be invisible underneath what's in the conical flask, okay? So you have your yellow precipitate or your pale yellow precipitate. It forms and you'll no longer be able to see the cross. So you're measuring the time that it takes for that to be obscured every time, okay? So you're going to get 3 marks for saying to put it on a cross marking or whatever kind of marking you use yourself. It can be anything. And then record the time it takes for the cross to become obscured. You could also, there's a different method that is done in some schools to set up a smartphone app called the Lux Meter. Okay, next to the flask, and record the time taken for each mixture to reach a certain opacity using this Lux Meter. And you're going to get the same amount of marks if you go through enough detail about the smartphone app. Okay, so now we've done question B part 1 and 2. Let's move on to question C, right? And question C asks us to copy the last column of the table into your answer book and fill in the missing rates correct to 3 decimal places. So here's our table, and we can see that this here is our missing column. So let's fill that out. Now we can see that there's not really much calculations required by us. We're looking for the rate, and it's telling us how to find the rate, 1 divided by t. So here it's 1 divided by 500, and you get 0.002. So the next one is going to be 1 divided by 200, and we'll see what we get for that. Okay, so we're going to need our calculators for this question. So the next one is going to be 1 divided by 200. And that is 5 multiplied by 10 to the power minus 3. So that is 0.005. Okay, now let's go on to the next one. It's going to be 1 divided by 109. And that is 0.00917. Okay, but it's correct to 3 decimal places, so it's just 0.009. Okay, and keep filling it out in your calculator like so, and you should get the following results. Okay, and for this question, you're going to get 6 marks, so 1 mark for each of your values that you filled out. Okay, so now let's go back to the question. So we're done question C. Question D now asks us, the first part of question D asks us to plot a graph, okay, of initial reaction rate versus temperature. So what we're going to do is I'm going to get a snippet of the box we just filled in, and we're going to graph reaction rate versus temperature. Okay, so here's my box from the last part C, and we are graphing temperature versus reaction, okay, or rate of reaction, okay? So the first thing you need to do is draw your axis using a ruler, of course, and label them. So we have temperature in degrees Celsius, and we have rate in 1 divided by the time, okay? So for labeling these, you're going to get 3 marks. So let's draw that down there. Now, you're going to get another 3 marks for doing accurate numbers on your axis, okay? So you need to make sure that you're going up to the right temperatures, okay? So I've gone up to 80. You could probably just go up to 60 because you can see it stops here at 59. Then you have the rate here. The last rate is 0.111, so we're covered here. So now let's start plotting them. So the first one, we have a temperature of 0, and we have a rate of reaction of 0.002, okay? So temperature is 0, which is here, and I'm just going to use purple pen to plot 0.002, okay? So we have here, this is going to be 0.01. So 0.002 is probably going to be about here, okay? Now the next one, temperature is 13, so it's probably going to be somewhere maybe around here, okay? And the rate of reaction is 0.005. Okay, so it's going to be halfway up between the bottom and this dot here. So there we go. Next temperature is 22, okay, and the rate of reaction is 0.009, okay? So we have 22, which is probably maybe here, and it's 0.009, so just underneath this line of dots. There we go. Next one, temperature is 33, and the rate of reaction is 0.018, okay? So we have 33, maybe somewhere around here, and 0.018, just underneath our 22, or 0.02 mark, so maybe right here. Next one, temperature is 40, and the rate of reaction is 0.029. Okay, so just label that as well, or plot that. Okay, next one, temperature 51, and the rate of reaction is 0.63. So 51 would be about here, and the rate of reaction 0.063. Oh, I just realized there that I've made a mistake with my axis. I've left out 0.06. Okay, so I'm just going to fix that. Okay, so that's a good sign to always do your graphs in pencil, because if you make a mistake, it's much easier to rub it out. So we were at temperature 51, and the rate of reaction was 0.063. Okay, And then the last one, temperature is 59 and the rate of reaction is 0.111. Okay, so now you have all 7 points are plotted, okay? So you're going to get 3 marks for plotting them accurately, and you'll probably be more accurate again using graph paper, okay? And as I said, just to reiterate the fact, you should always be doing your graphs in pencil because it's very easy to make a mistake with them. Now, the last 3 marks, okay, are going for doing a smooth curve of the shape. Now, this is something I personally always struggled with for my Leaving Cert. I just think it's quite hard to join the dots. So I would recommend just practicing drawing these. If you're doing exam papers, don't just skip over these questions and say that like it's easy to draw a graph. Do practice drawing them because you could lose marks for not having a smooth enough graph, okay? So I'm just going to give it my best shot here. Okay, it's not the best graph you'll see, but a smooth graph will give you 3 points. Now, you're going to be deducted 1 point if you do a poor curve or if each point is connected by a straight line as opposed to a curve. Okay, so this is 12 marks altogether for drawing your graph for this question. Okay, so now let's move on to the next part. So we've done D part 1. D part 2 asks us to use your graph to find an approximate value for x in the following statement, okay? So it says that the rate of this reaction doubles for every x degrees Celsius rise in temperature. Okay, so now let's look at the graph for this. Okay, so the rate of reaction, right, that I used to see this, right, was, and this is actually from the table, right, but I just thought it was the easiest way to go about it. You can see now that it doubles from 0.09 to 0.18, okay? So it doubles here, right? And what's the temperature difference? 22 to 33, okay? So 11 degrees Celsius jump. So that is going to be my answer, right? So you can see that it doubles, the rate of reaction doubles when the temperature increases by 11 degrees Celsius. Now, if you want to have a look at this in your graph, okay, you can see that, and I just noticed there that this doesn't go through that point. Okay, so just make sure that it goes through every point, your curve. Okay, so you can see here that, and I'm going to use my yellow pen for this, when it goes from 22 to 23, or to 33, okay, it more or less goes from 0.01 to 0.02. So the rate of reaction is doubling, okay, and the temperature is rising by 11 degrees. Okay, so my answer for this is 11. There was a bit of leeway in the marking scheme, okay. I think it was between 9 and 11 or 10 and 12 or something. So for my answer for this was 11 degrees Celsius, okay. And for this, there was 6 marks going. Okay, so yeah, if you got anywhere between 9 and 11, you got 6 marks. And if you got 3 above or 3 below, so maybe 13 or you got 7, you would have got 3 marks. Okay, so now let's go back and let's do the last part of question D. So we've done D part 2 and D part 3 asks us to explain this result. So we're explaining why for every 11 degree rise in temperature, the rate of reaction is doubled. Okay, so this is down to the higher temperature causing more effective collisions between particles, okay? So there is 3 marks going for this question altogether, right? And what I said is that at a higher temperature, there are more effective collisions between particles. And why is this? This is due to the activation energy. And what is activation energy? You'll remember that activation energy is the minimum energy required by reacting species or reacting particles in order to undergo a specified reaction, okay? Or the rate of reaction in this case, okay? So this is due to the activation energy being more easily reached at higher temperatures, okay? And that's something that you would have learned for the Leaving Cert, that at higher temperatures, there is more of a chance that the activation energy is going to be reached, which will then result in more effective collisions, okay? And then a higher rate of reaction. So this is 3 marks altogether for this question. Okay, so now let's move on to the last question, which is question E. We're told that the student then carried out another run 8, at 40 degrees, okay, but in a conical flask of a different shape to those used previously. As before, you still have your 10 centimeters cubed of 3 molar hydrochloric acid, and they were added to 100 centimeters cubed of 0.05 molar sodium thiosulfate solution. And the reciprocal of T in run 8 was 0.015 seconds to the power of minus 1, okay, which is 1 over T. So in question I, or question E part 1, we're told to show by plotting it whether the corresponding data point, and it's 40, 0.015, lies on the curve you have plotted. So let's go back to our graph and see whether it does or not. So in the exam, you're not going to have to draw the curve again. You're just going to draw it on the same curve. And the point was 40, 0.015, okay? So let's have a look at that. I'm going to use the pink pen. So 40 degrees, and it was 0.015. So that's here, and it is not on the curve, okay? So let's go back, and we're going to just state that it's not on the curve. Okay, now let's move on to the last part of question E. So then we're asked, okay, was the depth of liquid in the flask used in this run 8 greater or less than in the original flask? And to justify your answer, okay? So the answer to this is because the rate of reaction was lower, the depth was lower, okay? So this is because the rate of reaction was lower than the previous trials, okay? More precipitate is needed to obscure the cross because the molecules are more spread out, okay? So in the original flask, it might have looked something like this, okay? And it's the exact same temperature, the exact same amount of sodium thiosulfate and hydrochloric acid, okay, in there. But the rate of reaction was higher, okay? So it must be the depth was lower, okay? So in this shaped conical flask, right? So it's the same amount in there, as I said, the same temperature. There was more precipitate needed to obscure the X which was below it, okay? Because there was a greater surface area, and also because the molecules in the flask are more spread out than they are here, okay? And because they're in a smaller environment here, there's more chance of them reacting, okay? So for this question, you're going to get 2 marks here for saying that the depth was lower, for choosing that conical flask. And then you're getting 1 mark for your justification. Okay, just to show you here, they were kind of giving you the options here. They were asking, was the depth higher or was it lower? Okay, and we justified why the depth was lower. Okay guys, so we've done question E part 1 and 2, which completes this question. I hope that you found my solution to this question helpful and that it might have cleared up any difficulty that you had with the question. It was a relatively okay rates of reactions question, and when we're talking about rates of reaction, you really do need to have good graphing skills, okay? So that's all for this video. Thanks very much for watching and for listening, and I'll see you in the next video.